Hey guys, welcome to Chapter 7, Lesson 1. Chapter 7 is the human population. And so tonight's reading, you should start here on page 179, where we're starting with the opening story of the environmental implications of China's growing population. Okay, so that's where you need to start. And then you're going to end on page 188, where it says those checkpoint questions. Okay, and you can expect those checkpoint questions to show up in your WSQ. All right, so let's get started. We're going to start off today with our first case study for Chapter 7, which is government population control. Right now, China has an estimated 1.3 billion people, or about 20% of the world's population. Okay, now, due to the fact that there's so many people, and a lot of China is not really usable due to its proximity to Russia, and it's super cold up there and things like that. It's kind of produced this consumption and pollution nightmare. So by consumption, I mean like the amount of people using these different resources like electricity and plastic and things like that. We're consumers. That's why when you go to the store, you're called a consumer. And it also creates a pollution nightmare. Like producing electricity for 1.3 billion people takes a lot of coal, a lot of oil, a lot of natural gas, okay? Now, in the 1970s, the government decided that they were going to institute this one-child policy, all right? And so as a result of that, there's been an increase in the number of abortions. And the number of abortions and sterilizations that have been happening over the course of time since the 1970s in China. A lot of baby girls are aborted, and a lot of people are either sterilized because they don't have enough money to keep reproducing, because people who want to have more than one child, you have to pay like a ridiculous amount in taxes in order for that to happen. So it ends up making a lot of people choose to be sterilized rather than risk getting pregnant. Okay, so yeah, like I said, increased taxes for more than one child. Now, we want to be increasing the standard of living. So China is kind of moving through this thing called the demographic transition, which we'll talk about tomorrow. And they're trying to increase their standard of living for all of their citizens, which ends up increasing resource use. So we know that people in the United States, we use a lot of things. We have a lot of materialism, and so our increased standard of living means that we use resources more, which is as opposed to some small African villages where they use almost nothing. Okay, so as we increase the world's population in these developing countries, we're actually going to increase a lot of the environmental footprint. Okay, so our study tip today is quiz yourself. There are a lot of practice multiple choice questions at the end of every chapter. My suggestion would be to find the answers and study those questions that fit into today's lesson. So after you've read, after you've watched the video, okay, after you've made some notes, then go ahead and quiz yourself so that you can make sure that you have the answers if you were ever to see those questions again. All right, now we are on page 180, where it says that scientists disagree on Earth's carrying capacity. Okay, so we like to use the letter K to denote carrying capacity. Now, every 5 days, like I said today in our building relevance piece, we are increasing by 1.8 million babies and decreasing the world's population through 800,000 deaths. Okay, which means we're having a net increase of about 1 million people every 5 days. Okay, now if you look at the graph down here, you can see that around 1600 was when the serious population explosion kind of happened. Now, scientists disagree on what's causing those things, but for the most part, at the start of the agriculture revolution, we had the ability to not have to forage for food. So we could bring food to us instead of having to go out and find food. Okay. Then we had the Industrial Revolution, where there was a lot of people moving into the cities. We could find food at the grocery store. We didn't even have to make it ourselves. Okay. And then we had increase in sanitation, Okay, which means the number of deaths decreased, but the number of births kept increasing. Okay, so more sanitation means more births and less deaths, which would be good, you would think, but not for like the overall world population. Okay, it's causing this explosion. Now, the big question is, are human populations constrained by limiting factors? Are we limited by anything? Now, there are a couple of ideas about the human carrying capacity. There's a dude named Thomas Malthus, and we're actually going to have a Socratic seminar about some of the stuff that he was talking about later this week. And he said that the human population is growing exponentially while the food supply is growing linearly. And so eventually the human population will exceed the food availability, and that will be our carrying capacity. So if you look here, okay, this top graph is the indication of what Thomas Malthus said. So he said that as the population size is increasing exponentially, so it's going up, the food supply is going to be this linear dotted line, and eventually when the human population goes past it, we're going to have this deficit, and that's going to create a carrying capacity. So then our human population line is going to have to even out right there, like wherever our food capacity can be. Now, other people said that the more people that are born, the more innovation and technology are going to be available, which is going to alter the carrying capacity. So these are going to be technological advances. So far, it's been like agriculture, industry, and now more recently with our genetically modified organisms. Okay, so the second graph down here is about that. So population size is increasing. Okay, once we're kind of in danger of a food shortage, then we have some sort of innovation that pops us up. And we're going to go up and then pop up and then go over here a little bit and then pop up again. Okay? All right, now, demography is the study of human populations and population trends. Those are the people who are, counting and taking the census and kind of studying population pyramids and things like that. All right, now there's a few factors that influence changes in population size, and now these formulas are not going to be the same for nations or national governments or national populations versus global populations. So let's talk about that. Crude birth rate is the number of births per 1,000 people per year. So if you took a group of 1,000 people in, say, the United States, how many births would there be? Okay, and then it's kind of just an average. It's an easy way to take an average. Okay, same with crude death rate, number of deaths per 1,000 people per year. Okay, and this is usually every nation or every country will have their own CDR and CBR, and then the global population will have its own CBR and CDR. Okay, so the global population growth rate is CBR minus CDR divided by 10. You guys did that today for different countries, and you calculated it as a percentage. Now, something to remember for the future is that national population growth rates have to take into account immigration and emigration. Now, today we didn't because this was kind of an introductory situation, but in the future you're going to need to remember immigration and emigration. Okay, so national population growth rate, because we have people going in and out, CBR plus immigration minus CDR plus emigration. You might remember this from the population growth POGIL that we did at the beginning of chapter 6. Okay, and don't forget to divide it by 10, and that gives you a percentage just like the global population growth rate. Okay, now if the population growth rate is constant, then we can use our doubling time formula. Okay, so doubling time in years is the 70 over the growth rate. This is called the rule of 70. Now, the growth rate, I know it's a percentage, but you need to put the whole number as a percentage in here. So if the growth rate is 5%, you're going to put 5 here, not 0.05. Okay? Now, scientists estimate that the human population will be between 8.1 and 7.6 billion by 2050, and will kind of stabilize at anywhere between 6.8 and 10.5 billion by 2100. So that is determined by 100 million different things, and we're going to talk about some of those things today. Okay. first we're going to talk about fertility. Okay, and we measure that in TFR, which is total fertility rate. Okay, and that is the estimate average number of children each woman will have through their childbearing years. So childbearing year starts when a girl gets her period and ends when she goes through menopause. Okay, those are her childbearing years. So this is the average number of children per woman. Okay, now in the US that number is approximately 2.1. So we all know someone who has a giant family, like 8 siblings, okay, 8 kids, and then we all know the families who have like 1 kid or 0 kids. Okay, and so that all averages out. If you take all the children in the world divided by the number of mommies, that gives us about 2.1. Okay. Now, replacement level fertility is another way that we measure fertility in a population, and that's going to be the total fertility rate required to keep the population size stable. Now, that depends upon pre-reproductive mortality, so how many children die before they are old enough to reproduce. Okay? Now, if you live in a country that has a lot of disease or a lot of war or a lot of problems in general, then your replacement level fertility has to be higher because the chances of a kid dying is pretty high. But like here in the United States, I think our replacement level fertility is about 2 because we have a very low risk of kids dying before they're old enough to reproduce. Okay? Now we can kind of use these numbers to put countries into 2 categories. Developed countries have a high level of industrialization, a high amount of income, and the replacement level fertility is about 2.1, kind of like us in the United States. And then developing countries, they have a low amount of industry. They are usually pretty poor, sometimes less than $3 per day per person. They have a high amount of mortality in young people, so a high number of young people are dying, and their replacement level fertility is greater than 2.1. Now, I do have a common misconception card here. Developed nations do not have a lower environmental impact than developing. Okay, so developing countries have a higher population and lower green technology like renewable energy and things like that, but developed people use more per capita. So as a nation, the United States has more renewable resources that we use, okay, but we use more per person. Like, since we can afford more things, we usually buy more things, rather than like over in China where they have a lot of coal that they're burning, which is why their air pollution is such a big problem, but they don't use as much per person. Okay, so hopefully that makes sense. All right, next we have life expectancy, which is the average number of years an infant is expected to live. Okay, so when a baby is born, its life expectancy is according to what year it is. Because obviously if it's like 1300 versus 2015, the life expectancy is going to be a lot different, and it depends upon what country the child is born in. Okay, now if the country has a lot of health care, then you're going to have a longer life expectancy. However, a longer life expectancy leads to more resource use just to take care of you as you get older. Now, life expectancy is reported by demographers in overall per country. So what's the overall life expectancy per country? Then it has the males only and the females only, kind of like an age structure diagram. Now, usually females have a higher life expectancy than males because they are less prone to most diseases, and they do not, or they used to not really go to war. They didn't really go to war, and they don't have as high risk of jobs. Okay, so the average life expectancies around the world is in figure 7.5. The global average is about 69. U.S. average is about 78. Okay, so you can see the lowest are the yellow and the orange countries. A lot of sub-Saharan Africa and this one random country over here in Asia are the lowest. Okay. Next we have infant mortality, which is absolutely one of the worst subjects to talk about, is dead babies. Okay, so infant mortality is a number usually of deaths in children that's less than a year old per 1,000 live births. Okay, so this doesn't count like stillborns or anything, that, or abortions or any baby that dies while it's still in the womb. It's how many kids die once they're out and they're living and going in the world, and then they die before their first birthday. Okay, now child mortality is the same thing, only it's any kid under 5. Okay, so usually countries with a high life expectancy has a low infant mortality, and countries with a low life expectancy has a high infant mortality. So high life expectancy and low infant mortality is due to a large amount of available health care, plenty of available food and nutrients, clean water, sanitation, and moderate amounts of pollution. Low life expectancy and high infant mortality is usually due to lower amount of health care, little food available or little nutrients, dirty water, little sanitation efforts, and increased pollution and exposure. So exposure to toxic chemicals and radiation and all kinds of nasty things that people are exposed to around the world that we wouldn't even think about here in America. All right. Now we have aging and disease. The increased number of old people is the increase in crude death rate. Obviously, if you have more old people, in your country, then you're going to have more people dying per year, okay, even if your life expectancy is pretty high. Now, disease is one big thing that regulates the human population. Infectious disease is basically anything that's caused by a pathogen. Okay, it's not a genetic disease, it's something that you get, okay, is an infectious disease. Infectious diseases are the number 2 killer of people after heart disease. Heart disease is the number 1 killer of people. As far as infectious diseases go, HIV is number 1. TB and malaria are number 2 and 3. HIV turns into AIDS. If you didn't know that, we'll talk about it more in chapter 17. Most of it is happening in sub-Saharan Africa. A lot of things that people are doing now is trying to introduce contraception and especially barrier contraception like condoms to make sure HIV isn't spreading as fast. And if you look at these graphs over here on page 184, where the life expectancy is so short around here and the infant mortality rate is so high, one of the main reasons behind that is HIV. Okay, because these are the places that are the highest number of cases of HIV. Okay, and so that's what's kind of affecting those numbers. All right, so now we have our age structure diagrams. Okay, and this is going to be how a population is distributed across age ranges of 5 years. We did those today, and now we have 3 categories of age structure diagrams. Number 1 is the population pyramid. It's really little at the top and really big at the bottom. There's more young people than old people. This is pretty typical in developing countries like Venezuela and India. This means that the country is going through a rapid growth, okay, because as soon as you have an increase in these, as soon as these kids grow up to be, 20s, they'll be able to have even more kids. And so it's just going to get wider and wider and wider and wider at the base, because the more moms means the more kids, okay? Not a lot of family planning in these areas. Okay. Now there's something called population momentum, and that's the time for birth control actions to catch up with the growth. So China implemented a 1-child policy, India implemented a 2-child policy, but it's going to take a while due to population momentum for that to actually make a difference in what the age structure diagram of that country looks like. So that's due to our friend population momentum. Okay. Now our second kind of age structure diagram is the more column or rectangle shaped. The number of young people is approximately the same as the number of old people. That means you're having stable growth. Okay. A lot of developed countries are this way, like the US, Canada, Australia, Sweden. We should actually see an increase in countries that have column age structure diagrams soon, because every country is kind of understanding the limit to their resources and the fact that human population plays such a big role in it. Okay, and then last but not least, we have the inverted pyramid, where we have way more old people than young people. The total fertility rate is less than 2, so there's most families don't even have 2 kids, okay, 2 or less, all right, and maybe sometimes 3. These are countries like Germany, Italy, Russia, all developed countries. China will be here soon, or at least that's their hope, okay, so that China will eventually get out to this shape, okay. So if we want to look at that on the scales, here we have India, and they have rapid growth because they're the regular pyramid. Here we have the United States. We're starting to become the column here, so as these people are growing up, it's going to become more of a column shape, but there's not really any drastic difference between babies and middle-aged people, okay. And then here we have Germany, which we're having the inverted pyramid situation, so we're getting smaller and smaller and smaller as we go down, okay. And so as these people get older, it's going to become more and more of an inverted shape. And then we have China, which is attempting to do the same thing. It's just taking them a little bit longer because they have so many people. Okay, if you look at this, population size in millions, this is 1, 2, 3, 4. This goes from 0 to 70. Okay, so the numbers on the bottom make a huge difference, guys. Okay, so we need to make sure that we're looking here as well as here. All right, next is migration. A lot of nations care a lot about migration. Okay, we know the United States and our borders are usually pretty open, okay, as long as you kind of do it legally, I guess. In Syria, they're having the problems now where, well, not in Syria, but in Europe, they're having a lot of refugees trying to get in their borders, and they're getting a little upset about it, and a lot of things happening with migration. So, the movement of people doesn't affect the world population, duh. It affects national populations or populations of countries. People are displaced because of disease, natural disaster, environmental problems, or war, then leads to crowding, decreased sanitation, and refugee camps, which are horrible. Most of the time, we're going from developing to developed countries like Mexico to the United States, which actually increases the ecological footprint and resource use, because a family is going to use way less resources when they live in Mexico than if they live in the United States, because here in the United States we have a very materialistic mentality. Okay, so that's going to transfer on everyone that migrates here. Okay. All right, here we are, the end of lecture day 1. I'll see you tomorrow.